we're meant to graph both of these on this graph here. So first we're going to graph f of x equals e to the x, our exponential. And by the way, these are both inverses of each other, if you didn't notice that, because this is e to the x, that's logarithm base e of x. Well, anyways, let's graph this one first. Our typical exponential, we should expect it to go like this. But we know that when x is 0, e to the 0 is 1. When x is 1, e to the 1 is e, which is roughly 2.72. And when you have -1, e to the -1 is 1 over e, which is about 1/3, a little bit above 1/3. So we got some stuff there. And by the way, we also have this nice horizontal asymptote at y equals 0. That's our typical one for an exponential equation like this. And that makes sense. As x gets super, super negative, this gets close to 0, but it never goes negative. So we can see it hugging that vertical asymptote here and then kind of shooting up like this. Now when we come to ln of x, let's do that in red. And again, a typical logarithmic function is going to look like this. And if we've done it correctly, it should look symmetric to e to the x across the line y equals x, that diagonal line. So let's just plot a couple points. Let's see how it looks. So first of all, I know I'm always going to start with ln of 1 because a log of 1 is always going to equal 0, right? So that means when x is 1, we've got this nice x-intercept here. We also know that since this is log base e, e to what power is e, right? So that means when I'm plugging in e for x, I should get 1 because e to the first power is e. So 2.72 roughly for x should give me a function value of 1. And we can also think ln of 1 over e, which is the same as ln of e to the -1. This is saying e to what power is e to the -1? -1. So what does that tell you? That tells you when you plug in 1 over e in for x, which is about 1/3, then you're getting a value of -1 for the function value, so something like this. So you see these points kind of mirror these 3 points there. And by the way, since we do have this natural log of x, x cannot be 0 or negative, which means we have a vertical asymptote there, and then we kind of hug the asymptote as we go down. Hug this vertical asymptote as we go down, and then shoot off like this to the right. And there you have it. So there's ln of x in red, there's e to the x in black. That's how they look together. Done.